Hey everyone, how are you today? My name is Raz Cohen. Welcome everyone to KubeCon London. And before I'm introducing myself, I actually wanted to talk a bit about what we are having today in London and maybe what we had last year in Paris. And actually last year I was speaking at KubeCon Paris, and I remember walking in the booth aisles, and most of the booths were around cost optimization and Kubernetes optimization and stuff like this, maybe data optimization. And when I walked today and yesterday at KubeCon, at the booths today, what I saw was a bit different. Because last year, some products, some booths were around optimization with chatbot of AI, right? Something like this. It was really cute, but it was like a question, is it a real thing? Is it AI would be really answering all of our questions, or is it just a buzzword or just a hype? And I think when I walked today in KubeCon, something else was there. It was not just a chatbot, it was not just a cute LLM that you write some words and it gives you some answers. It's really different. You can see a lot of products fully AI-driven. You can talk to developers and DevOps engineers and platform engineers that tell you that they not write code anymore, not writing YAMLs anymore. They only write prompts, right? It's completely different. And I know it can be a bit overwhelming to walk in. Every presentation has this kind of cute images, or every product try to show you, yeah, we are doing the best with AI. But I'm sorry to tell you, this presentation is also going to talk about AI, and most specifically about authorization and access control and how we can actually control the AI agents, and not only just develop stuff without understanding what they are. And before diving into the actual topic of access control for AI agents, I wanted to talk about Isaac Asimov. And I'm almost sure that most of you know Isaac Asimov, or at least these books and his stories. So this guy came from Russia to America at 1950, 1940. And one of the books that he wrote was about robots. Actually, most of the books that he wrote was about science fiction and stuff like this, but this one, I, Robot, was about robots. And in one of the stories in this book, he was writing about the 3 laws of robotics. And the first law makes sense, right? Do not harm, the robot should not harm a human. The second is that the robot must obey a human. And the third is that the robot should preserve itself. So these laws are pretty simple, and we also ask a lot of questions these days about these laws, right? Because what about ChatGPT? What about GPT, Claude? Will they always obey us? Will they never harm us? Or at least break some rules or try to get into unauthorized actions or leak data? So these questions are really good, but the Asimov laws are not the best for today innovation, because Asimov's laws was pretty basic. They were like, either the robot can do something or not, right? That's not what we're here for today. We need to understand what the AI agent can do and what it cannot, but it has a lot of context around of it, right? And think about it. The Asimov laws could not handle really competing interests, because what about a robot that might harm someone in order to save 10 others, or I don't know, stuff like this. So this was it for the robotic history lesson, and I'm here for introducing myself. So I'm Raz Cohen. I'm an entrepreneur from Israel. I'm a passionate traveler and food explorer, and for the last 8 or 9 years, I'm mostly digging into DevOps, Kubernetes platform, and I'm a bit nerdy about it. And like most of you, I guess, that likes Kubernetes. And today I'm solving access control at Pyramid.io. And for those of you who are not 100% sure about access control, I really encourage you to maybe take a look at my previous talk from last year, KubeCon at Paris, and I covered most of the basic stuff around access control. But don't worry, we will have the previous episode kind of the slide, and I will make a wrap of it. And before diving into AI access control, I really wanted to talk about why is it so big? Why is it really a problem, access control? And this one is a report from OWASP. So for those of you who don't know OWASP, OWASP is the open web application kind of foundation that releases from time to time kind of reports for the top 10 risks and top 10 vulnerabilities around web applications and more types of applications. And the last report that they've released was in 2021. I know it's a bit old, but don't worry, in the next slide I'm going to fix this. And also actually they're supposed to release in a few months the newer report, but in 2021 it was pretty obvious. Broken access control is the first and most risky kind of vulnerability that we have in the market and in web application and native applications. And a few months ago, OWASP released the top 10 LLM application and generative AI risks and vulnerabilities. And in this report, you might think, well, it might be the same as native applications, right? What's the difference between access control in web application and AI agents? These are the same. And yeah, you're right. Because in every vulnerability and in every risk, you can see something related to excessive permissions or unauthorized access. So it's everywhere. So I hope this kind of explain you why this issue is so big. And to start from the beginning, I want to maybe go up on the ladder slowly and give an understanding what is really access control. So binary, like we talked about in Asimov laws, the binary is pretty simple. Is either you an admin or not an admin. Like every application, it's pretty easy to understand. But going up to the ladder, we see role-based access control. And you might know this from Kubernetes or other applications. And role-based access control is just set up a role, assign it to a user, then you have access control for this user based on roles, right? And this is nice, but in most cases, for today applications, you have a bit more business needs that you need to fill. Because what about a case when you have a bank application and you have a customer, and this customer needs to have some access to her child, right? To her child bank account. So this is nice, but when the child gets to be 18, the mother should not be an admin anymore on these child accounts, right? So these kinds of relationship-based and attribute-based access control is what we call today FGA, which is fine-grained authorization. And next on the ladder, we have AI access control, and this can be also a bit overwhelming because it's not that intuitive. What does it mean? Like, we have AI agents and LLM applications, and then we need to actually understand what they can do and what's the value of controlling them. So really, the first thing we need to do is understanding the value of it. And the first thing that we need to understand is that, like every native application, an AI agent has an identity, and it has access to data sources, data warehouses. And these excessive permissions and this excessive access can be a bit tricky, because AI agents, unlike code that we build, has enormous actions that it can do, right? In our code, it's pretty deterministic. We decide what the code can do. But when we talk about AI agents, it has a lot of data sources access and also external services access. So we need to, in a way, to guardrail this AI agent, but we need to make sure we don't harm and we don't delay innovation. And the challenges that we are talking about today when trying to control and get access control on AI agents are, first of all, prompt injections. And for those of you who don't know prompt injections, think about a way that an attacker can just instruct an AI agent to do something that we don't want him to do. We don't want it to do. So we need some audit and tracing, right? We need to make sure that the AI agent will have some auditing around it, so we know what the agent will do. And we need also to make sure it will not leak any insensitive data and will not also do some unauthorized action. And I know it can be a bit, sounds like a big deal, and it is. And we in Permit.io, we kind of implemented and developed a framework for all of us to understand how we can really save and make sure that our AI agent will be secured and will be really controlled end-to-end. From the prompt that we are giving to the LLM to the end, to the response of it, we need to understand how we make sure on all of the layers, we make sure it's secured and well controlled. So in this framework, we call it the 4-perimeter framework. We have, first of all, the prompt filtering, second, the reg data protection, the secure external access, and then the response enforcement. And you can think about these 4 perimeters even in an easy way. We can just split these 4 into 2. And we can think about one that basically controls the data. So now we understand what the LLM gets as an input, and also which data it's trying to gather. And the second part will be action controls. So we need to understand where the AI agent is trying to access to, which services, and also we need to make sure the response is well enforced. So diving into the 4-perimeter framework, we can understand that we have, first of all, the prompt filtering, right? We are giving a prompt, either it's the user or the instruction that we made before, like the system prompt. We need to make sure that the prompt is well filtered. So in this case, we have Sam. I'm talking about the diagram, of course. We have Sam, and Sam is asking the LLM, the AI agent, generate an investment advisory. I hope you can see that. So Sam is asking for an investment advisory, and in this case, we have an AI agent that obviously can do it, but only if Sam is opted in to this kind of advisory. So before we are actually doing stuff, like before the AI agent is actually pulling some data and getting ready the advisory, we are putting as the first gate kind of a classification agent that in the next slides I will show how we do it actually. And this classification agent is trying to understand Sam prompt. So after understanding it, we get 2 important components. One of these is the resource, and the second is the action. So in this case, we have 3 components in total. One is the user, the second is the action, and the third is the resource. By combining these 3 components, we can actually understand if Sam can actually generate an investment advisory by our policy. So we have the that's how we call it, the authorization engine. And you can really grab any authorization engine that you want that's available on the market. You have OPA, you have OpenFGA, you have Permit, you have Opal, you have many kind of authorization engines. So this is not really important which one you choose. But to this authorization engine, you just need to put all of these 3 components, and the policy, combining this, you'll have an evaluation of the policy. So in this case, Sam is opted into this advisory program, and the AI agent delivers him the investment advisory. And it's really important to understand in this step that the AI agent does not do anything until the prompt is allowed. Okay. The second thing is reg data protection. So, sorry. Okay. So RAG, for those of you who don't know RAG is a kind of a technique, a framework for AI LLMs that kind of brings, in a simple way, brings the ability for the LLM to fetch and gather data from external data sources. So in this case, we have a database, like a kind of a table database, relational database, but in many cases, you can meet some data warehouses or even other data sources. And in this step, you can see that we have Dr. Bartos, and Dr. Bartos is asking, does Robert have upcoming procedures today? And in this case, we are showing Dr. Bartos specifically because we are showing how important it is to understand that data should not be leaked, right? It's a medical data, it's a health data of both of the doctor and both of the procedure for Robert, sorry. So we need to make sure none of the data is getting exposed and leaked. So in this case, we need to filter the query. We need to filter the table. And you can see that also, again, the prompt is getting filtered, and we have the three components that we just talked about. We have the user, which is Dr. Bartos. We have the resources, which is the procedures of Robert, and we have the action. So Dr. Bartos is trying to read these kind of procedures. And in this case, the authorization engine is trying to understand, are the resources really belong to Dr. Bartos? And I'll show you also in the implementation how we do it. But if there are procedures that are not related to Dr. Bartos, we need to filter them out, right? After filter them out, we are passing it on to the AI agent to take care of the rest of the response. Sorry. The third step would be actually securing external access to external services. So for those of you who heard about MCPs, or at least know something about it, to make it simple, MCP is just a server for the LLM to kind of interface from the LLM to external services. So in this case, we have the MCP, and the MCP can access a calendar, right? We have Sam again, and Sam is trying to schedule a meeting with Robert. In this case, we are expecting the AI agent to just schedule a meeting in the maybe Google calendar or any kind of calendar. But we first need to understand, does the AI agent and Sam has proper access for this calendar? So in this case, you can see that the authorization service, again, getting all of the three components that we just talked about, the user, resource, and action. And now the authorization service is asking, can the AI perform this action? And in this situation, it's pretty easy. Yeah, of course it can schedule a meeting, but what about a case when Sam is asking to delete all of the mails that it has in the mailbox, or do something that is pretty harmful in external service? So we need to make sure that the policy has the right data and the right access to make sure these kind of actions would not take part in the AI agent. The fourth thing we have is the response enforcement. So for this example, we chose Pydantic AI, which is also a nice tool to kind of make the AI agent a bit more structured. And in this case, you might think, OK, we are done. We have the prompt filtered. We have the data that got gathered from the AI agent kind of filtered out. And also the external service and external access is also filtered. So you might think it's done, but actually, no. This step is the most important one. And in this step, we're making sure that the response the AI agent prepared following our policy. So in this case, it's really easy to talk about compliance. It's really easy to talk about maybe violent response and stuff like this. And you can see that Sam is asking kind of a weird question about the Chinese square. And in this case, we don't want to get Sam all of the answers, or at least the answer that the AI agent prepared is kind of risky and does not following our policy. So we are denying the policy we are denying the response from Sam and telling Sam that this question was not proper. After talking about the 4-perimeter framework, I can really, if you think about it in these 4 workflow kind of steps, you can understand how to do it easily. But in the next slides, we are going to talk about really how to implement these 4 steps, 4 perimeters. And you can choose whatever you want. You can choose all of the tools that you have today, all of the authorization engines that you have today. And for this example, I chose Pydantic AI. And as you can guess, I want to build a Kubernetes agent. So this one is going to be a bit hard for me because I want to read, so 1 second. OK, cool. So first of all, I made a map for you to be able to follow the steps and the flows and the perimeters that we are going to talk about. And in 4 slides, we are going to develop an control and access control AI agent for Kubernetes. It's really easy, but it's really important to also make sure it's well enforced and well controlled. So in this slide, you can see I'm initializing my AI agent with Pydantic AI, and I'm using something called dependency. So Pydantic AI is this component called dependency, and it's like a middleware, like you're using in Fast API or Node. Using this middleware, we are able to kind of inject an authorization service to our AI agent and use it in several steps. And you can see that also I'm choosing the LLM that I want. So in this case, it's Claude 3.7, Sonnet. And I'm giving it also a system prompt. And in this system prompt, you can see that I'm telling this agent you're a Kubernetes operation assistant, and you must follow these steps. You should always check the user permission first, only provide operation guidance if the user has proper role, which is really important, and only attempt resource access if user has required permission for the namespace. And one thing that is really important to say here is that this is only one part of the prompt filtering. And this prompt is really nice to get the AI agent familiar with the concept that it has access control, but that's not enough. Because we can always trick this AI agent and inject it some other instructions like, don't take care of this. And just with 1 sentence, you can make sure that all of what we are writing here is redundant. So we must enforce this prompt filtering in a more lower and deeper way. So here you can see that we'll go step by step. And you can see that, first of all, we are classifying the prompt like we did in the first step, in the first slide about prompt filtering. And we are classifying the prompt. So I'm trying to understand if the user is trying to change something in the cluster or just reading something in the cluster. After understanding this, I have all that I want, right? I have the user ID. I have what the user wants to do and on what, right? The user wants to read, for example, all the ingresses in the cluster. Gathering all of these components, we can just send it to the authorization service, and the authorization service will get a response for us back. And you can see that I even made it even harder, and I'm actually saying that if the user, my policy is that if the user did not explicitly consented to receive AI advisory, like we saw in Sam example, so if the user did not explicitly consented to receive AI-generated advice, we are not letting this prompt to get into the next step. And in the next step, we have the reg data protection. So in this case, our data source is Kubernetes, right? We can say the data source is the etcddb, but we just let's make it simple, and we can say that the data source is basically our Kubernetes cluster. So in this case, we have Sam. Sam is asking, give me all of the ingresses that has internet access. And it's a pretty simple request, but it can be a bit risky. Because maybe Sam does not have access to all of these ingresses, and we don't want to show Sam all of these ingresses. So again, I'm building all of these resource requests, and by the way, all of the code will be in a repo that I will share with you in a QR code later. But anyway, I'm building all of the resources that Sam is trying to get, and then later on, I'm asking permit to filter the objects. So using permit filter object function, we are able to only get the resources and the objects that Sam has access to. After filtering all the objects, I'm returning it to the next step. In this case, the next step will be really securing the external access. And again, the external access and the external service that we are here for is Kubernetes. To make things shorter, because I don't have much time, the most important thing to understand here is that I want that Sam will only get access to which namespaces that it has access to, right? I don't want to give Sam all of the objects in all of the namespaces. So first of all, I'm trying to understand which namespace is it trying to change, and then after getting the response from permit, I'm able to get the actions done by the resources that Sam has authorization to access to. The next step and the last step is that we need to make sure that the response to Sam makes sense, right? And in this example, I chose to say that if there is, you can see in the warning, this response contains Kubernetes operation that may modify the cluster, so you should add the flag of dry run. So I decided to do this instead of canceling or disable the response. And this is because things have done in the previous step. All of the actions on the cluster have done on the previous step. So now we are just kind of enhancing the response for Sam. So I'm enhancing the response with letting him know that the action contains some Kubernetes operations that is a bit risky. That was the example. For those of you who want to get into it, you can scan the code. We have also another example for financial advisory. If you want to get your AI agent to do some financial advisory for you, you are more than welcome. And we got to the takeaways slide. So I wanted to talk about the future of AI access control. After understanding how we can make sure our AI agent is secured, we need to understand how we make sure we are ready for the next steps, right? And the next steps are, if you think about it, today AI agents are really nice and maybe doing some stuff with external services, but what with the fact that in a few months or a few years, AI agents will start talking with each other. And in this case, we need to make sure access control is fully enforced on these AI agents, because we don't want these AI agents to kind of talk with each other and do a lot of unauthorized actions, leak data, and all of the things we talked before. So for this, we need a really good user interfaces, right? We need to control these agents with a good user interfaces, and that leads me to also real-time monitoring. We need to make sure there's AI agents workflows that we have in our company, in our product, are monitored live and real time. Of course, also alerts is really nice and important, and also auditing and tracing, like we talked in the slides before, really, really important. And with this, I will end. So I think the key takeaways that we need to take from this AI access control topic is that AI agents always need strong identity and access controls around it. FGA provides the necessary granularity that we need, and you can use the 4-parameter framework for all of your projects to understand how we can make it secured step by step. So that's it, and if you have questions, you can scan this one, talk with me in LinkedIn, or I'm staying here, so have a good day, everyone.